Mobile also I connected.
Okay, okay. I will share the screen. One second.
Mm.
Okay. Visible, no, properly?
Yeah, visible.
So we'll see that frame structure.
Mm.
Frame structure LT. So frame structure means like how the resources, no, resources are allocated to UEs. Let us say
Mm.
time domain. This is frequency domain. So
Mm.
uh, multiple these are like subcarriers. How they will divide?
Mm.
One resource block will be like a uh, very big I made. Okay. So up to this, let us say this is one resource block. We'll understand what is that resource block. Then we'll break down
Mm.
all the subframes, frame and all.
Mm.
So like this is like so many resources will be there.
Mm.
So part of that resource will be allocated to the UEs. So once we
Okay.
are allocating something to the user, so we need to tell no like this much resource is needed for the UE. So
Mm.
unit is required. For example, every quantity, no, this much water will be given. So everything will be have some unit. Same way,
Mm.
resource also will have that unit. Okay, so I mean, not resource. Resource have the unit
Mm.
that's called resource block. In terms of block,
Mm.
like resources are given. So this will be given like time plus frequency. So it is like two-dimensional unit you can tell
Okay.
because the user will be given some time and user will be given
Mm.
at a particular frequency also. That is where both things will come, time also, frequency also.
Frequencies. Mm.
So just remember, this is the two-dimensional unit representing frequency and time both. Okay.
Okay.
So resource block will represent time also, frequency also. Okay. And E node B allocates resources, allocates resource to UE in terms of resource block. Like, see, there is a huge resource, so huge time and huge frequency. But
Mm.
assignment will be done based on resource block. Blocks will be given to the UEs to send their symbols and all. And who will assign? E node B will give. That you have to remember. Okay. E node
Okay.
will provide these resources.
Okay.
Okay. And yes, I will see that zoomed view of that uh, one resource block. So we'll see this one resource block, how this one will look like. So we'll focus on this part only. Okay. I'm trying to
Okay.
zoom that resource block.
Mm.
Let us say it will look something like this. That one resource block only I'm taking.
Okay.
Okay. So this will have 12 subcarriers. Okay. It will have 12 subcarriers. How many? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. 2, 3. So it will start from 0 to 11. This will go. These many
Yeah.
subcarriers.
Mm.
And what is that? We can like time slot 0, like till 0.5 millisecond. It will be like 1 millisecond. 1 millisecond. It's like one subframe. Okay, in this time domain. So half of that subframe, 0.5 millisecond, that is called TS0. So in resource block, till 0.5 millisecond only will be considered, and
Okay.
subframe will go till 1 millisecond.
Okay.
Okay, and this is in this time domain. Again, it's further divided.
Yeah.
Okay, 1, 2, 3, 4, 5, 6, 7. So these are the 7 symbols.
Okay.
Okay, 7.
7 symbols in frequency domain, right?
No, no. See, it is cutting here, no? This one.
Mm-hmm.
So we can tell this is in time domain actually.
Okay.
Okay. Frequency domain, like subcarriers are there.
Oh.
So in frequency domain, there are subcarriers, 12 subcarriers.
Mm.
And in this time domain, there are 7 symbols. And also 7 symbols or 6 symbols that will depend on cyclic prefix. If it is cyclic,
Ah.
cyclic prefix, then 7 symbol,
Mm.
normal cyclic. If it is extended cyclic prefix,
Mm.
so 6 symbols. So these are the symbols.
Okay.
So one symbol,
Mm-hmm.
see, the symbol, no, it has nothing to do with the frequency. This whole part, that maximum where till the end point it can go, no?
Yes.
That is one symbol. Make some different color. This one vertical pole, this one. This is one symbol. Okay. This is second symbol.
Mm.
So this symbol has nothing to do with the subcarrier. Okay, no, the symbol doesn't know how many subcarriers are coming on the way. Simply just a pillar. This is one symbol, this is
Mm.
one symbol, this is one symbol, one symbol. How many subcarriers are there? No need to talk about that. No need to calculate that.
Okay.
Okay, so 1, 2, 3, 4, 5, 6, 7 symbols and 12 subcarriers. This comes in one resource block. Understood, no?
Yeah. Okay. Mm.
Okay, so
Okay. If it is normal cyclic prefix means 7 symbol, extended means 6 symbol it will come.
correct.
The
So
12 subcarrier is fixed.
12 subcarriers is fixed in one resource block.
Mm-hmm. Yes.
12 subcarrier multiplied by 7 symbols. So this will give how
70.
many these small blocks are there. This is small block is nothing but resource elements.
Mm.
Okay. So how much this will become? This will become 84 resource element. Correct?
Yes.
This is in case of
Mm.
normal cyclic prefix. If it is
If it is
extended
extended,
cyclic prefix, then 12 subcarrier multiplied by 6
mm,
symbols.
72
72 resource element.
element.
Okay. These are small elements. Okay, so here point to note that is, first of all, you have to remember 12 subcarriers are there in one resource
Mm.
block.
One
And
resource plug, yes.
and these symbols, 1, 2, 3, 4, 5, 6, 7 symbols. But
Mm.
symbols is what? It doesn't mean this one block. This is one block is resource element only. Symbol is like
Okay.
this entire vertical thing.
Yes.
Just remember this thing. This is very confusion for some people. Okay,
Mm.
this is one resource block. So
Mm.
go here.
See,
We
inside
talk
the resource block having multiple element, right?
multiple resource elements, either
Mm.
84 or 72.
It depends upon the cyclic frequency.
So whatever this whole thing we discussed, no resource block,
Inside that one.
that is this one part only. Then
One
same,
part, understood.
then same thing will repeat here. Same thing will repeat here.
Mm,
Okay, means here seven symbols,
mm,
then here seven symbols, then here seven symbols.
mm,
But
mm,
but entire here will be like 12 subcarriers only.
mm.
Okay. Then here another block will come, resource block. Here will be like
Okay.
same thing. Symbols are seven only.
Simple.
But here again, then 12 subcarriers. So here 12
Carrier only.
subcarrier, here 12 subcarrier, here 12 subcarrier.
Mm.
Okay, until it reaches maximum 20 megahertz in that LTE band.
Okay.
You understood, no, this point?
Yeah, yeah, understood, understood.
Okay. So I will ask you some question. So how many symbols in one resource block?
See, symbols are normal cyclic prefix, 7 symbol it will come.
Hmm.
For extended cyclic prefix, 6 it will come.
Correct. Hmm. And uh, okay. So bandwidth of each resource block. So bandwidth will be, see, first of all, 12 subcarrier, okay?
Yeah.
Okay. Each subcarrier will be of 15 kilohertz. Okay. This subcarrier, let us say one subcarrier. This will be 15 kilohertz.
Mm. Subcarrier spacing of LT 15 kilohertz.
This one 15 kilohertz, then 15 kilohertz, then 15 kilohertz. This 12 subcarriers I'm telling, no?
Yeah,
So,
each subcarrier having 15 kilohertz spacing.
correct.
Okay.
So, this entire, how much this will become? 15 kilohertz multiplied by 12.
12.
Correct, no? So, this will become
Mm.
something 180 kilohertz.
Oh,
Okay, now look at the bigger picture. So, this is 180 kilohertz, this much, 180 kilohertz. Then this one
mm.
is again 180 kilohertz. Then top of it
Okay.
again one more resource block will come, that is also 180 kilohertz.
Until our frequency band, either
Our,
20 or 15 or 10.
correct. Okay, maximum is 20 megahertz. So it will there will be a block of
Mm.
180, 180, 180, 180, 180 like that.
Mhm.
Okay. So one subframe. Okay, one subframe means
Mm.
see one resource block will be till this much. Okay, one
Mm.
resource block means zero point 0.5 millisecond. But if I will consider till 1 millisecond, if I am considering till 1 millisecond, so that will be like one subframe.
Mm.
Okay, one subframe. We'll draw this again. Okay, this is one resource block. This is one
Okay.
resource block. Okay, zero point 0.5 millisecond. And this will be like 12 subcarriers here. 12 subcarriers up to this point. Also, this is no, like 180 kilohertz. This will be okay. And here, like seven symbols, I'm not drawing. Otherwise, it will become more complex. So,
Mm.
like one more resource block, let us consider here. This is also zero point 0.5 millisecond. So this will become a 1 millisecond.
So, mm.
So this is one subframe.
Okay.
So
Mm.
what is one subframe? One subframe means in time domain 1 millisecond, in frequency domain 12 subcarrier.
Mm.
Okay. So this entire will be called as this much will be called as resource grid. Okay. This is resource grid. Resource grid means one subframe. Wherever one subframe, it just think as another meaning of 1 millisecond only. So these are used
Hmm.
interchangeably. Okay. Somewhere mention 1 millisecond
Okay.
means one subframe only. Somewhere
Okay.
one subframe, just take it as a 1 millisecond only. Okay, this is like known
Okay.
terminology.
Hmm.
So resource grid means one like one subframe up to
Hmm.
12 carrier with 12 subcarrier. Okay, so resource
Okay.
grid means this one. One resource block up to like 1 millisecond, but height will be like up
Hmm.
to 12 subcarriers only. So now you understood
Okay.
the difference between resource block and resource grid.
Yes. 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 Yes.
Okay, so resource block will be this much till 1 millisecond
Hmm.
will be resource grid.
Okay.
Understood, no?
Yeah. 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 Yes.
Okay, so just I will summarize few things. One frame, okay, frame I didn't cover here. So this is one subframe, okay. So same like when 10 subframes will come here,
Okay.
when 10 subframes will come, that will be called as a
Hmm.
one frame. Okay, one frame means 10
Hmm.
subframe.
10 millisecond or one frame?
Ah, correct. One 10 subframe you have mentioned, so the same you can mention here as a 10 millisecond.
10 millisecond also.
Okay. So one frame means either 10 subframe or 10 millisecond. But you can
Hmm.
visualize here, no, like when 10 subframes are stacking one after other, that will be called as
Hmm.
one frame.
Okay.
You are able to visualize, right?
Yeah. Yeah.
Like 10 subframes, then one frame. For example, one train, no? In train,
Hmm.
like only single compartment is there. That will not be called as a train,
Hmm.
no? So
Yeah.
let
Yeah.
us say
That is single box.
then like 10 blocks came, so 10 compartment came. Okay.
Hmm.
Then we call it a train. Same way,
Then,
they're like subframe. When 10 subframes are there, then we call it as a one frame. So frame, no,
hmm.
think it like a train only.
Hmm. Ah.
It's like a train where many subframes are there. One millisecond. 10 subframes, one train.
Okay.
Okay, like so. Now you tell me in one subframe, normal
Hmm.
cyclic prefix, how many symbols are there?
Normal cyclic prefix one subframe is uh, normal means 7.
No, no. See, what I'm asking. In 1 millisecond, one subframe,
Hmm.
resource block was there till 0.5 millisecond.
0.5 millisecond.
See, you are in seven symbols are correct,
Uh,
but
into
that was in resource block up to zero point
hmm.
0.5 millisecond. I'm asking in 1 millisecond. So seven symbols plus seven symbols.
14 OFTM symbol.
You understood, no? Why 14? Seven symbols
Mm-hmm.
were there in resource block. So resource block is of 0.5
Okay,
millisecond. Now
okay,
I'm
understood,
asking how
understood
many
clearly.
symbols in one subframe. One subframe means
Uh,
till this point. So here seven
oh,
symbols, then here seven symbols.
okay.
Okay, no? So
So
14 symbols. This is normal cyclic prefix.
mm,
Okay,
most
so,
commonly used symbol.
hmm. So if I will ask you how many symbols in resource block, so you will tell seven symbols.
Mm,
But I will ask how many symbols in resource grid or how many symbols in one subframe. So subframe you have to
Mm.
count till 1 millisecond. So you will tell 7 plus
Mm.
7, 14, right?
Mm.
Clear, right? No doubt, no?
Yeah, yeah, yeah.
Mhm. More things. So, what else? Okay, huh. So how many maximum subcarriers will be there? So maximum bandwidth in LTE is
Maximum
maximum bandwidth
maximum bandwidth 20 megahertz.
20 megahertz. No?
Mm.
It is ask, I'm asking like how many total maximum numbers of subcarriers. So how will calculate maximum bandwidth divided by one subcarrier
Mm.
specifically. So once you will do this, this will come around 1200 subcarriers.
Mm.
Okay, this is important. Many times it will be asked.
Maximum subcarrier in LT.
Uh, okay, so it is like 1200 subcarriers.
Okay.
So also like for bandwidth of LT, like 1.4 megahertz, 3 megahertz, 5, 10, 15, and 20. How many resource blocks will be there?
Yeah, yeah, it will be depends upon the band.
Uh, 6, 15, 25, 75, and 100 resource blocks. Okay, so how this will come? It will be like should be some calculation. I'm forgetting. Hmm, 100 resource block. Okay. So based on that, see in one resource block, 12 subcarriers will come here, right? Or I can tell 180 kilohertz. Hello? Hello, Karthik.
No, I'm audible or not?
Now you are audible. So,
Sometimes
uh, but I am audible, right?
yeah, yeah, audible only.
So let us say this one resource block, no? Based on
Mm.
this 180 kilohertz, no? So how many stacks
Mm.
you can get, once 20 megahertz?
Mm.
Based on this 180, like each subcarriers will be like 12, how much is that? 180, 15 kilohertz. So these many,
Mm.
how many stacks will come? It will be like 100 resource blocks.
Mm.
Even if you will calculate, no? See,
Mm.
100 resource blocks will be having in one resource block, how many? 12 subcarriers, no?
Yes.
Okay, so 12 subcarriers. Even this will also give you 1200 subcarriers.
1,200 subcarrier.
Okay, so
Mm.
uh, so in terms of if you want to calculate how this 100 came here, that also you
Mm.
can do like 20 megahertz,
Mm.
and in one block how many are there? 12, right?
12 subcarriers.
So I will divide by 12, no?
Mm.
No, no.
If you divide, it will won't come.
Not 12. I think I have to do by 180, yeah? 180 kilohertz. And how much it will come? Where is the calculator? One second, I'm just calculating. See, once I will do this 20 megahertz divided by 180 kilohertz, no? This will come
Mm.
something triple one. Okay,
Yes.
here it should be 100 resource block. So this is not
Mm.
exactly same at is. At the middle now, some carriers are reserved for the pilot carriers. Some buffers are
Mm.
there. So,
Correct.
but it is coming close to the 100. So like it is not exactly one,
Mm.
but excluding those reserved subcarriers, then it will be like 100 only. But the like
Mm.
calculation is same. Like
Mm.
you will remember that number of subcarriers. Each subcarrier is 15 kilohertz. So
Mm.
we can like get that
Mm.
concept like how it is coming like this 100 resource block, 75 resource block, 50 resource block like that.
It is 12 subcarrier spacing. Uh,
Mhm.
okay. Our concept is 12 subcarrier. Subcarrier spacing is 15 kilohertz.
Hmm. Correct. Hello.
Yeah, yeah. Tell me.
Uh, yeah, yeah, you're correct. You're correct. Okay, so main thing what you have to remember is this is frame, this
Mm.
is subframe.
Rape subframe.
Hmm. Subframe like 1 millisecond.
Mm.
Again,
Frame means 10 millisecond.
1 millisecond. This will be like in 0.5 millisecond will be one resource block. This is one resource block.
Mm.
Okay, and then here seven symbols plus seven symbols.
Mm.
So
7
14.
symbol, 14 writing symbol for one subframe.
Uh, and here will be like 12
7
carrier,
subcarriers, 12 subcarrier, sorry.
in one resource block. One
Mm.
subcarrier will be 15
15
kilohertz.
kilohertz space.
So 15 kilohertz multiplied by 12, this complete will be 180 kilohertz.
Mm. Yes.
Okay, same thing will repeat above then.
Mm.
It's like entire frame structure.
Mm.
So 10 millisecond, this
Mm.
one frame. Okay, this will go up to 20 megahertz. So maximum subcarriers, number of subcarriers will be 1200 subcarriers in 20 megahertz bandwidth, maximum subcarriers. Okay.
300. Mm.
And how many this
Mm.
stack will come?
Mm.
Stack will come 100, 0 to 99.
Mm.
Okay. And
Okay.
here once you will divide that subcarrier, here seven symbols. So here it will be total 84 resource element in
84.
normal cyclic prefix.
Mm.
Extended cyclic prefix will be 72 resource element.
Yes.
This entire frame structure of LT. Mm. And E node B will allocate the resources to UEs. Okay, so
Mm.
question is there like who will allocate the resources? E node B will allocate the resources.
Mm.
Okay. Everything is covered already. Okay, then this is complete. Tomorrow we'll see resource block of not resource block, frame structure of 5G.
Okay.
Hmm.
We just comparing 4G to 5G for every topic. Huh?
Not every topic.
Mhm.
Because if I will directly tell you 5G frame structure, no, you will get too much confused. So for the sake of 5G frame structure, then I told you 4G frame structure.
Mhm.
But mostly our series will be it is for 5G only. Wherever it is required, there I will cover some 4G topics. With some
Mhm.
dependencies there, or mostly I will focus on 5G part only.
It's good only.
Mhm. Okay. Okay, then I will stop this recording.
Mm.
How to stop that recording? Uh,